Hey, everybody. We're going to get started. Thank you. So welcome to Adventures in Whimsical UX, the tug-of-war between delight and performance. So the other day, my phone prompted me to uninstall a bunch of unused apps. And I got to thinking about how that makes me feel. Honestly, it's one of the few things that my phone does these days that gives me a genuine sense of relief. And usually it's a relief at finally cutting ties with an app that I know does not deserve my attention in the first place. Rarely do I stop my phone from following through on what's basically the App Store's own garbage collection. I can count on one hand the apps that I would actively fight to keep. They're almost all ones that I sought out myself, even paid for, a friend suggested to me, ones that made a big positive impression. They're also the ones that made me feel like I got more value out of them than they extracted out of me. And I really hate to say this out loud, especially on a stage, and especially being an Android developer from the very start, but I think more of the apps that I think back on that made those impressions I experienced on iOS instead of Android. And that has always bugged me, because I know that it does not have to be that way. Part of this is simply a built-in platform advantage of a smaller, more premium, homogeneous device ecosystem like Apple's. But over the years, I've thought a lot about why that gap has kind of persisted. Despite huge leaps in hardware and frameworks, programming languages, design patterns across both platforms. And I've also thought about how KMP gives us fresh opportunities to deliver really delightful experiences to all mobile users. The apps that did make an impression, the really great ones, they were apps that felt like they were built specifically for me and my devices. They differentiated themselves on UX, sound, and haptic design. These apps were not choking my phone with storage bloat, abusing my data plan with their telemetry, draining my battery just to render a minimalist card layout. They pushed the boundaries of the hardware, but they were usually pretty performant. And when they did stutter or show any jank, it was because they were doing something genuinely cool at the really edge of what that device could do. And I had patience and respect for that, both as a user and as a developer. Which really makes you think, how do you develop an app that nobody would want to uninstall? I think this has something to do with whimsy. Or I should say, I think the antidote to what's wrong with many apps today is that we've drifted too far from users while metrics maxing for business advantage. Whimsy gets a bad rap because we tend to equate it with useless design bloat. But whimsical features are intentional choices that are designed to spark delight in your users. It's the app acknowledging that there is a human being on the other side of the screen. Cool. It's you, the developer, reaching through the glass to boop your user on the nose sometimes. And these apps are, they generally evoke positive sentiment and show personality. That's the kind of impression that you remember and tell your friends about.
As developers, we've been encouraged to embrace minimalist UX for a long time. Early mobile just couldn't do much else due to device constraints, but the hardware we have now is often more powerful than laptops. Yet we still stick to simpler UX because it's easier to design, to build, to test, and to automate. But another underlying business driver, minimalist UX is much easier to monetize and to A/B test on. It gives you clean, predictable surface to experiment on. So many of our design choices ultimately boil down to business incentives, right down to shipping our org chart sometimes. We've also learned hard lessons in incident rooms. We've been burned by some harmless-looking change that goes sideways. These can arise from anywhere and from any feature, but there's nothing quite so ridiculous as having to explain why a sparkle animation caused a P0 incident in the middle of the night. That's a true story. And when your P75 performance metrics are struggling on 3-year-old hardware already, it can seem like you don't have any budget left for delightful UX. When Lori and I led mobile platform teams at larger companies, we often tried to help feature teams through these exact kinds of trade-offs. I remember when we first introduced Compose at Reddit, teams that embraced it early were delighted by the power of the framework, but they also ran into performance foot guns regularly that scared off other teams, at least in the short term. When teams didn't push through these challenges and learn to profile and tune for performance, they end up wary of taking calculated risks in design and implementing features that users notice as active, visible investments in making an app better.
It's the same story when teams wanted to use animations or short videos in their user flows. Those teams faced pretty hard choices. Bloat app size by megabytes with heavy assets that were maybe used once or twice, or fetch them remotely and inherit all the failure cases that come along with that approach. Many a feature team does the napkin math on this in bulks, deprioritizing the very features that would make their surfaces memorable and better. Depending on a team's aversion to risk, even adding micro-interactions, sparkles, or shared element transitions can feel like a big ask, especially when a team is under pressure. These features carry intimidating downsides with no immediate, easily measurable upside for the business. So why bother if they're not going to move the needle on the business? Well, if you take this to its natural conclusion over time, your app will become generic and it loses what made it special in the first place.
And that is exactly how your app ends up on the ropes or uninstalled. The moment a newer, more interesting app that serves a similar purpose comes along and grabs the user's attention, they're gone. Maybe it's a competitor, or maybe it's just a vibe-coded clone a user built for themselves and their friends. Either way, you've lost a user. And look, more of these apps are coming. We're in the middle of a massive shift in mobile development, and the barrier to entry has never been lower, especially for personalized apps. I mean, if you believe the hype, building a native app now is just as easy as ordering a coffee.
A hypothetical user, let's call her Erica, can describe her app in simple language, answer a few questions, pick a palette and a font, and one-shot a functional clone of fairly straightforward apps. And immediately, she gets that special feeling that that app was made just for her and her devices. It's not one trying to extract maximum lifetime value from her. This app doesn't need to scale. It doesn't have to resort to one-size-fits-most UX design. It can have flair and personality and whatever ugly gradients and animated buttons her heart desires. Her app doesn't need telemetry. It doesn't need session tracking. And it doesn't have to carve out some of its prime real estate for advertisers. And in the process, she takes back some of her agency as a user. She's getting the utility that she wanted from her device in the first place. So think on this. Her vibe-coded app may very well be more performant than an app built to scale and use far fewer network resources, simply because it's not doing all of that other stuff over the wire.
I love this for this suspiciously named Erica, but it should give the rest of us in the business of mobile development some pause. Even with the constraints and concerns around vibe coding, these one-off apps have a lot more opportunity to show personality and flair, and completely bypass many of the constraints traditional native teams have had. And that is going to put pressure on us to find ways to make a better impression with users and to build features they've never imagined their phones could do before. And that is where craft comes into play. It's engineers like the ones in this room who can show and extend what mobile is truly capable of and unlock these new experiences for users. We understand the difference between a demo and a deployable feature. We feel the gaps in APIs that need implementations and extensions. Most apps still barely scratch the surface of device capabilities, meaning we have plenty of room to innovate, even if consumers slow down on upgrading their devices and stay on them longer.
When you're experimenting with UX, it's important to understand the business decisions that are often getting made about what ships. And many of today's apps have been hyper-trained, that's a Pokemon reference, to session time, revenue, click-through rates, to maximize these specific metrics. And that's just what we have come to recognize as shareholder value in tech. But in the process, they've diluted the actual value that they're providing to the end user, squeezing those margins quite a bit. We've built very lucrative tech empires over-indexing in those directions, but sometimes to such extremes that we are starting to deliver poor user experiences that need some balance. This matters here today because a powerfully visually interesting feature can easily fail an A/B test if it steals the show from a modest, monetizable feature, lowering the metrics the business cares about. Perhaps you've meaningfully improved performance, but you reduce session time in the process. Or your eye-catching animation draws attention away from a nearby prime ad spot, lowering revenue. Navigating those business trade-offs is tricky, but apps that balance the business priorities and the user priorities well are the ones that the users remember. And that brings us back to Whimsy. It's not just novelty, and it's not meant to be so transactional. So with that in mind, let's talk about how we can actually deliver more of these features with Kotlin Multiplatform without venturing too far into the risky places that end up in incident rooms.
Not so fast, Lori. We've got one more problem to contend with. Many of the best examples of production UX polished today aren't actually there for user delight. They're dark patterns dressed up as premium design. They're basically elaborate interactive ads and other high-impact visuals, often weaponized to signal the top of a product funnel. These tactics pull users towards some form of conversion, and while that's not a bad thing on its own, over time, abusing these patterns can really hurt user trust if those experiences do not benefit the users themselves. As a result, these practices, users often become more skeptical of eye-catching UX elements, and really, who can blame them? What's frustrating is that most developers don't want to build things this way. We care about our users, and we want to build features that matter for the business. Just look at our weekend projects and internal hackathons. We're always building inspiring demos, and many of those ideas rarely reach users, not unless there's a monetization angle along for the ride. Because if you give them more value, you also have to balance that out with more revenue for an experiment to be seen as truly business net positive. So how do we break out of that cycle? How do we establish more trust with users so we can reclaim some of those opportunities to build experiences that are more creatively interesting and rewarding for everyone involved?
It's not easy, but it's a lot easier for us because we are exploring these questions with kids. And this is a niche user that people seem to recognize these tactics are especially problematic. So that helps us operate as an indie company that can experiment with different approaches on how to align businesses with user needs. And a lot of what we learned is, over the past few months is actually really applicable to the larger teams we used to work with.
I can't believe you just called us an indie company on this slide of all slides, Lori. All right, let's get the ball rolling and do some demos. One thing we have not mentioned yet is this talk is actually a live Kotlin demo. This is an app running. So it's built fully in Compose. It's actually built within our app's code base. So everything we'll be showing are real components and sometimes whole screens hosted within our slides. So if it moves, it's real content from our app. There's no GIFs or videos here. So everyone, please join us in crossing your fingers that our presentation doesn't crash.
When Eric and I decided to start a company this past year, the main question we asked ourselves was, how do we make kids' apps suck less? Because let's be honest, the state of kids' apps is an embarrassment to our industry. As parents, we've searched for and found few that we'd be comfortable giving to our kids. And we thought, well, we literally can't make this sector any worse. And we had good reason to believe we might be able to change it for the better. For years, we've been building apps just for our own families, as many of you have too. Apps that amused our kids, didn't turn them into mindless zombies. Apps that we built with creativity and a lot more opinionated design. But until recently, trying to scale experiences like that felt out of reach. But then the day came when the convergence of KMP and Compose Multiplatform and AI efficiencies reduced our business constraints by orders of magnitude. And we thought, well, maybe now's the time to give it a try. And conveniently for us, and helpful for you, is that kids don't do subtle. In our space, Willy Wonka-style shared element transitions are at least potentially a justifiable choice, which gives us a great sandbox to experiment in. We can build colorful spaces full of responsive components and lean heavily on visual nav, like our main menu here, which serves as a launch pad for adventures, but also tells the time with the sun. But Whimsical UX is not just for kids. We want to make sure you understand that we're trying to make these applicable to everyone. We live in a world filled with many different device form factors, especially on Android, and business incentives often push teams to design for the lowest common denominator, and it shows. Adaptive mandates are a great excuse for engineering, design, and product to rethink how they're working together. And especially since AI is forcing us to have those conversations anyway, it's a good time. Rethinking adaptive design in a multi-platform context has been incredibly rewarding for us. These conversations allow us to avoid the architectural pitfalls we know from experience are really hard to fix later, like supporting accessibility, orientation changes, edge to edge, good networking and caching strategies to support offline modes right out of the gate. And while these are not particularly whimsical features, they go a long way to help users feel like you have purpose-built the app for them and their devices. And so one thing to take away from this is, before you can deliver delightful, functional is a good place to start. And especially when there are so many apps that fail at even this exercise on large screens or in portrait mode.
All right, so let's get practical. Good UX performance starts with using modern asset formats. It's usually an easy lift to migrate your app assets, so if you're still using legacy ones, consider phasing those out for some easy wins. This alone can bring down your app size, improve your cold start times, and speed up loading and rendering at runtime. The user may not see a change, but they will feel it. And upgrades like these can buy back budget and goodwill to experiment in other areas where changes would be more visible. Let's look at some asset types specifically. To start, no more PNGs. For raster images, WebP is the standard. It gives you the same transparency and quality at the fraction of a size. I'd love to tell you to use AVIF everywhere. The compression is incredible. But reality is that backwards compatibility just isn't there yet for older hand-me-down devices. Because of that, our approach focuses heavily on using SVGs. To make these work well without forcing the awkwardness of async loading, we built a soon-to-be open-sourced library and lots of internal tooling to help keep our apps lightweight, scalable, and fast to render and animate as needed. Let's talk about some animation frameworks. For years, Lottie has been the standard. But let's be honest, it's gotten a little heavy. It relies on larger JSON files that just aren't flexible enough for the adaptive world. So we have moved on to Rive, a framework powering visually tech-forward apps like Duolingo and Spotify. Rive uses a lightweight binary format that's typically 10 to 15 times smaller than Lottie, but the real magic is in its interactive runtime, state machines, and performance. And its rendering engine is highly optimized on mobile GPUs and built for adaptive UX. Lottie's playing catch-up by adding state machines, but Rive is already pushing ahead into 3D rendering. Sound and haptic feedback give experiences more of a game feel, and a little goes a long way. Just make sure to keep up with modern format recommendations and experiment with quality settings. Those make a big difference in file size and performance. And for streaming sound and video, make sure you're using adaptive quality and bitrate design patterns upfront these days. The speaker notes on this slide just say, channel Ryan Gosling and complain about the state of fonts and mobile. Fonts are heavy, costly, and grabbing them OTA can loop in extra third-party tracking and other concerns. We don't have great advice for you here, other than there are unsolved problems here we're solving if you are so inclined.
So now let's look at a few easy, low-hanging fruit ways to improve your design techniques, especially for adaptive designs. Next. Gradients get a bad rap, but they can do some heavy lifting for adaptive layouts. We routinely model 7 screen layouts in Figma and Compose previews to cover a lot of our devices that we want to support. We use multi-step gradients to functionally glue screen elements together across a variety of screen sizes and orientations, and they help absorb the awkward gaps that can happen, and they keep the number of our design breakpoints pretty low. Compose Multiplatform handles linear, radial, and even mesh gradients pretty easily these days, especially if you're not animating those mesh gradients. They're lightweight and great for keeping app sizes down while providing some visual interest. We also use functional gradients, which are a lot like functional colors that convey meaning. So here's a simple example where we've got a weather feature and we're changing our sky gradient to reflect different types of weather. We've removed the clouds and precipitation so you can kind of see it. But we use this for everything from modeling atmospheric conditions to haze to water depth.
Gradients are so common now that they don't really differentiate your app anymore. Textures can make your app feel handmade and less generic, but they can easily bloat apps and tank GPU performance unless you go with fuller featured game engines. To solve this, we built seamless vector tiling library called Quackers, which we open sourced this past winter. If you're wondering why a library would be named Quackers, it's because we name all of our open source projects after words that our kids mispronounce.
so we have to say them on stage.
Yes. Tiling lets us use tiny vector assets to build rich, textured experiences that pack more punch. Here on the left, we use tiling to create distinct branded game pieces. And on the right, we use a subtle low opacity pattern that adds texture to a background gradient. You know our feeling about fonts now. They're challenging to work with, so it's probably good that it's probably a good thing that most of our users can't actually read yet. Ultimately, we realized that since we don't need robust typography support, we could pre-render the text that we actually use. While this doesn't work for every app, it's the first app I've ever worked on where it would work. It's definitely worth considering what performance taxes you're paying that aren't providing any value, like font support was for us, and working to strip those out for efficiencies. It's strange that we as an industry are still collectively wowed by glass effects and morphing a circle into a squircle. On modern GPUs, we should be way past this. Material 3's expressive design was promising in that it had some opinionated designs, but its shape morphing was limited to a handful of pre-canned shapes on Android. We built out morphing arbitrary shapes so we could morph puzzle pieces, letters, numbers, you name it. As long as the geometry is clean, performance is very solid. This is another soon-to-be open-source library. It's perfect for shared element transitions, but we have some functional morphing use cases too. For instance, here we built out a full facial expression engine that our mascot uses. Particle systems are foundational to game feel, and we've built out quite a few of them now. We use them for small moments of celebration, like confetti, but we also use them for environmental effects, like weather and bubbles. These effects can be highly efficient, but it is one of those canvas drawing features where it's worth keeping a frame rate counter on and doing some performance analysis to optimize, since bugs and edge cases can result in performance degradations.
Finally, don't forget to pull features out of the app and into interactive widgets and wearable use cases, if you can. Thanks to some recent Android updates, it's also apparently never been easier. Here's a watch face that we made that's headed in that direction. It turns out that kids really like telling the time as long as the second hand has a pterodactyl on it. And now we just have to make the volcano erupt at the top of the hour, which is the other request. OK, so now let's talk about some of the ways that we use Compose Multiplatform, particularly with attention to shared element transitions. Our app uses games. Our app includes games like match and dynamic puzzles in different environments. So our games don't just take advantage of the different screen sizes and orientations that they can be played upon, but they also leverage subtle composed-backed physics animations to reinforce the setting. So for example, in space, the game tiles float a little in 0G. They sit firmly on the table on land. They drift in the water a little bit. And Eric, our kid testers, are really interested in more dinosaur content. So what should we do?
Maybe we can make the game tiles rattle when a T-Rex walks by. These types of motion are well within the capabilities of Compose Multiplatform, and animating a handful of composables around on screen is straightforward, even on older phones and tablets. Sounds and haptics can really add to the experience, even if they're only available on some devices. Just also really enjoy confetti.
Everybody likes confetti.
Shared element transitions are incredibly handy for us. By embracing visual navigation, our little old school and a little old school skeuomorphism, we get to build across locales, which helps justify extra investment in transitions that feel special. For example, when a kid taps the art palette, the palette itself moves into place onto the canvas and pops open, and they're ready to create their masterpiece.
Are you OK?
Oh,
I'm like, are you going to draw, or are you?
I could.
OK. We've also experimented with using shared element transitions for cinematic storytelling and lightweight cutscene style transitions. This is our app startup. We're mixing a sequence of shared element transitions with some bubble particle systems, a tiny touch of Rive for the swimming, and all of it runs smoothly without any major frame drops. We sometimes chain together transitions with an occasional interactive element. For us, these depict a change in navigational context or a sense of motion. For example, here we use animated overlays and path animations to illustrate movement as the user travels through space environments. So it's turning out that a lot of filmmaking and cartoon animation approaches lend themselves really well to shared element transition implementations. That's just one of the things we found by playing around. Jetpack Compose makes it easy to build eye-catching visuals these days, especially with shaders. But while these often look great in controlled demos, they can suffer in terms of perf on lower-end devices and are unavailable on older models and API levels. Relying on the newer APIs just adds code complexity, forcing you to maintain and test separate paths for old and new devices. At least for now, our test matrix feels complicated enough just to support the multiple platforms and the screen orientations and those types of things, without layering our code base with a lot of API checks. So we're biasing heavily on experiences that have good backwards compatibility, and that would be our recommendation, especially if you're a little averse to that kind of complexity. It keeps us honest and forces us to deliver the maximum value to users right now, rather than chasing APIs that many users won't see for years, if ever. However, they're really cool, and if your user base is future-facing and on these latest devices, then by all means, please start shipping those experiences sooner. They constantly tempt us.
Most visual effects are doable on mobile in some form, although how they are achieved may differ from game engine implementations. Parallax effects are a lightweight way to inject depth and layering into a mobile UI, and a little goes a long way. While traditionally a resource hog, modern hardware handles multi-layered panning easily if you cache your layers properly. With these sorts of features, if you want to keep the effects subtle, you do want to keep the effects subtle and ensure it's configurable for accessibility. Here we use a parallax pattern to give depth to our science labs, allowing users to pan around the room and look out the windows. Fun masking and visual distortions like magnification, blur, and glass effects add premium polish and wow factors, especially when coupled with edge-to-edge layouts. However, animating canvas distortions can absolutely impact your frame rates. It's normal for early prototypes to have some jank, but if you have to budget, you do have to budget for the performance reality and do some profiling of those experiences across different devices. But for smaller personalized apps, these are incredibly rewarding areas to play in, even without much fine-tuning.
So far, much of what we've shown you is doable entirely in Compose multiplatform. But now let's talk for a bit about what we decided to do when we needed to extend experiences into spaces that Compose isn't built for, especially around animation. For example, this is our main menu, and it's entirely in Compose multiplatform. But when we wanted to add a flag that flaps in the wind, or our mascot to swim or wave, Compose just can't really achieve those animations without a lot of extra work. In the early days of mobile, game development diverged from app development, and so did the store experiences. And many of the tools needed to truly build immersive experiences got stuck on the gaming frameworks. And they never really got built into the core mobile APIs. And we feel it when we've had to add things like blurs and other things like that along the way. Now, we want those features for more adaptive apps, but you don't necessarily want to go and pull everything in that comes in with game development. You just want touches of these things for your apps, like more visual menus or micro-interactions. Rive can do pretty much everything that Lottie can do, as far as we've been able to figure out. But it's also a lot more performant, and it's powerful enough to handle everything from widgets to full-screen, self-contained minigames. You package the art assets along with animation logic, the audio if you want it. You can localize them. They're definitely built more for mobile. We're still trying to figure out what the sweet spot is when you could choose Compose or Rive. And like all developers, we often reach for the tools that we know best. However, we get distinct advantages from choosing one framework over another. And a lot of this we learned from Duolingo. Here's our basic logic. If it's essential to the feature or a shared element transition, we use Compose. If it's a complex animation that needs rigging, or it's a brand asset that we want to also be able to use in a self-contained way on, say, our website or on socials or something, then we're going to probably choose Rive. And one thing to note is that if you're fine-tuning motion and easing a lot, the Rive IDE is still a work in progress, but it still is a much better experience DevX-wise than wrangling Android Studio previews with animation. We use self-contained Rive widgets all over the place, like this 120 beats per minute space-themed metronome. That's a long sentence. To bridge any load latency, we use a static vector fallback, which is typically the animation's first frame, so failures look good. We lean heavily on scalable vectors for animations in general, and use Rive's state machines and their data binding to drive changes. We use instances to organize variants in the same animation file, solos so you can reskin outfits and things like that. There's a lot of do once, use everywhere type of stuff. And mastering some basic motion design and easing will go a long way to keep your assets performant, because you'll learn how to keep your keyframe counts manageable. Rive is also pretty incredible for character animations and rigging. With Rive, you map vector content to bones to rig your model like a puppet, and we learned that from the Duolingo folks last year. Once rigged, you can then create movement sequences like swim cycles or walk cycles and manipulate those bones and change states. So this is our little app mascot, Eli. And on the left is the rigged skeleton, and on the right is a simple swim cycle with a hello wave and an expression change, each of which can be changed at runtime independently. And we even conditionally include props like a flashlight, and all in the same animation file. So it's an extremely smart file. Worth noting is that these are not pre-rendered linear animations the way we used to use in Lottie, which is why they're so much more performant. The Kotlin code interacts with these animations through familiar data binding and view model patterns that you're all used to. And these can be executed in many environments, not just mobile. They can be exported as vector graphics, animated GIFs, videos to use on socials, and old school slide decks for the people who don't make their presentations in Kotlin like big nerds. They're interactive, which means you can touch these spiders and they would react even on the slides.
We've also experimented with mixing native and Rive, which opens up some really fun possibilities. Take this weather screen. Native code handles the layout and the weather effects. The thermometer is a compose component. We have particle systems emitting rain and clouds. That's also in compose. And then with Rive, we can trigger animation state changes at runtime easily, like responding to changes in weather, reacting to bolts of lightning in his eyes, and more. But what if you want to go in the opposite direction and have an animation trigger native code instead, for instance, to access haptics? Here, we listen for an event fired by the Rive animation. At the exact keyframe, the snowball animation splats on the screen, and we fire a quick haptic pulse from native code that feels like a snowball is really hitting the screen. Communication in either direction has very low latency, which is perfect for near immediate feedback and game feel. We've also experimented with sound on both sides of the transaction. It really just comes down to where you prefer to package and pool your sound assets.
We're almost done, but let's quickly touch on how we approach design, prototyping, and testing. We've built a bunch of custom internal tools, heavily leveraging Claude at times, to speed up our iterations and wrangle optimized cross-platform mobile assets in more developer-friendly ways, which we knew just KMP on its own was going to be a challenge for that, and there were a lot of DevX things that we could play with there. But honestly, most of the most useful tools for UX work here are the exact same ones you should already be familiar with. Compose previews are where adaptive UX actually happens for us. Like we already mentioned, we have at least 7 variants that we test on every screen. And we find we are spending a lot less time building pixel-perfect Figma designs these days, and more time here.
We weren't going to include this, Cody, but one of the JetBrains people told us we should when we told them we made it as a joke. Previews are powerful and super handy when they work. We use them constantly to fine-tune our experiences, but we still run into fragile tooling headaches within Android Studio. Improving the stability of these features is the lowest hanging fruit for team velocity, especially around adaptive UX. There's an opportunity for IDEs and tool makers to prioritize the stability of these features, because a fragile feedback loop is one that you won't use or build processes around. As you've seen in this presentation, in addition to iOS and Android, we also build for desktop. We don't actually have a consumer market need there. We are never going to ship a desktop, or maybe, never say never, but we're unlikely to ever ship a desktop app. We do it purely because desktop builds are so much faster, and hot reload is so nice. If you haven't used it yet, I would really highly recommend it. It makes our feedback loops incredibly quick, which keeps momentum high, especially for a small team of 3. KMP development is becoming common, but testing strategies are still rarely discussed. Personally, we prioritize unit and screenshot tests because, at least for us, they offer the best balance of speed and reliability. We use deterministic randomness with seeds to achieve dynamic animations while still keeping our test results consistent and reproducible.
Finally, when it comes to testing whimsical designs, you might want to reconsider some of the old school user testing patterns. Designing for pre-readers requires us to scrutinize many mobile development assumptions and patterns and recognize that they have always utterly failed certain groups of users, especially in terms of accessibility. Having conversations with users also helped give us permission to try some more whimsical features because we are not imposing those things upon them so much as delivering what they've asked for directly. You've seen the memes. As developers, we build and assume that our work is going to be used one way, and then you watch your users, you will often find that it is being used in ways you never intended or imagined. That is especially true with kids. No experiment readout or automated test is going to be able to tell you that so clearly as when you watch them use your work. So if you take anything away from this talk, please let it be that you should look for ways to find more ways to connect with your users, perhaps by injecting a little bit more whimsy into your experiences. And performance is an important consideration when experimenting with design, but it's not really a hindrance these days. So please don't be afraid to add some of those personal touches to your apps and give that a try. It's make an impression or perhaps be forgotten. So we hope that you have found something to be inspired with for your projects today, and we'd love to hear about which approaches work well for you and your teams. So drop us a line. Thank you.